You have probably seen them everywhere, on restaurant menus, on posters, on product packaging, on tickets, business cards, payment screens, websites, advertisements, and even museum signs. Small black and white squares, filled with tiny patterns that somehow connect the physical world to the digital world in just a few seconds. These are called QR codes. QR stands for Quick Response, and that name explains their purpose very well. A QR code is designed to store information in a way that can be scanned quickly by a camera, usually with a smartphone. But even though QR codes look simple, there is actually a very clever system behind them. At first glance, a QR code may look like random black and white pixels, but it is not random at all. Every square, every pattern, and every empty space has a purpose. Together, they create a visual code that a camera can read and a computer can understand. A traditional barcode, like the ones you see on supermarket products, stores information in one direction. It uses vertical lines of different widths, and a scanner reads those lines from left to right. A QR code is different. It stores information in two directions, horizontally and vertically. That means it can hold much more data in a much smaller space. This is why QR codes are often called two-dimensional barcodes. Instead of lines, QR codes use small square blocks called modules. These modules are arranged in a grid. Some modules are black and some are white. The pattern of these black and white modules represents digital information. In the simplest sense, the black and white squares work like binary code. Computers understand information as ones and zeros. In a QR code, black and white areas can represent these different values, allowing text, numbers, links, and other data to be stored visually. But before a phone can understand the data, it first has to recognize that it is looking at a QR code. That is where the large squares in the corners come in. Most QR codes have three large square patterns, one in the top left corner, one in the top right corner, and one in the bottom left corner. These are called finder patterns. Finder patterns help the camera detect the QR code. They tell the scanning software where the code begins, how it is positioned, and how it is rotated. This is why you can scan a QR code from different angles. You do not need to hold your phone perfectly straight. The scanner uses these corner patterns to understand the orientation of the code and adjust the image automatically. There are also smaller alignment patterns inside many QR codes. These help the scanner read the code correctly, even if the surface is curved, tilted, or slightly distorted. For example, a QR code printed on a bottle or displayed on a wrinkled paper can still be scanned because the system can correct for some distortion. Another important part of a QR code is the quiet zone. The quiet zone is the empty white border around the code. It may look like wasted space, but it is very important. It helps the scanner separate the QR code from everything around it. Without this clear border, the camera might have trouble identifying where the code starts and ends. Once your phone detects the QR code, it analyzes the pattern of modules and begins decoding the information. The data inside a QR code can be different things. It might be a website link. It might be plain text. It might be contact information. It might be Wi-Fi login details. It might be payment information. It might be a ticket number or a digital coupon. One of the most common uses of QR codes is opening a website. When you scan a QR code on a poster, menu, or package, the code usually contains a URL. Your phone reads that URL and asks whether you want to open it in your browser. But the QR code itself is not the website. It is just a visual way of storing the address of the website. This is an important difference. A QR code does not magically connect to the internet by itself. It simply stores information. Your phone reads that information and then performs an action, such as opening a link, showing text, or connecting to Wi-Fi. Now, one of the most impressive features of QR codes is error correction. You may have noticed that some QR codes still work even when part of them is dirty, scratched, damaged, or covered by a logo. This is possible because QR codes include extra information that helps restore missing or damaged data. This system is based on error correction technology. In simple terms, the code stores backup information. So even if a small part of the pattern cannot be read, the scanner can still reconstruct the original message. There are different levels of error correction. The higher the level, the more damage the code can survive. But there is a trade-off. Higher error correction means less space for actual data, because more of the code is used for backup information. This is also why some QR codes look more complex than others. A simple QR code that only contains a short website link may have fewer modules and look cleaner. A QR code that contains a long piece of text, contact details, or more complex data will usually have many more tiny squares. The more information a QR code stores, the denser the pattern becomes. There are also different sizes or versions of QR codes. A small version has fewer rows and columns. A larger version has more rows and columns and can store much more information. However, in real life, it is usually better to keep QR codes simple. If a code becomes too dense, it can be harder to scan, especially from far away or with a low-quality camera. That is why many QR codes use short links instead of long website addresses. When you scan a QR code with your phone, several things happen very quickly. First, the camera captures the image. Then the software identifies the finder patterns and determines the position and angle of the code. Next, it corrects the perspective, so the code can be read as if it were flat and straight. After that, the scanner reads the grid of black and white modules. Then, it removes the masking pattern. A masking pattern is used when the QR code is created. It helps avoid confusing visual patterns, such as large blank areas or repeated shapes, that could make scanning harder. During decoding, the scanner knows which mask was used and reverses it. Finally, the scanner decodes the data and shows the result to the user. All of this usually happens in less than a second. QR codes became especially popular because they are fast, cheap, and easy to use. A business can create a QR code and print it almost anywhere. A user only needs a smartphone camera to scan it. There's no need to type a long website address, download a special app, or search manually. This makes QR codes very useful in many industries. Restaurants use them for digital menus. Stores use them for discounts and product details. Airlines and event organizers use them for tickets. Banks and payment apps use them for quick transactions. Companies use them on business cards and marketing materials. Museums use them to provide extra information about exhibits. They are especially powerful because they connect offline objects to online content. A piece of paper, a sign, or a product label can instantly lead someone to a video, a website, an app, a payment page, or a digital form. But QR codes also come with security risks. Because a QR code hides the final destination until it is scanned, users may not always know where it leads. A malicious QR code could send someone to a fake website, a phishing page, or a harmful download. That is why it is important to be careful. Before opening a link from a QR code, check the website address if your phone shows it. Be especially careful with codes placed in public spaces, because someone could cover a real code with a fake sticker. In general, QR codes from trusted sources are safe. But like any technology, they should be used with awareness. So what are QR codes? They are visual containers for digital information. They turn text, links, and data into a pattern of black and white squares that machines can read. They use special position markers, alignment systems, binary encoding, masking, and error correction to make scanning fast and reliable. And how do they work? A camera scans the pattern. Software identifies the structure. The code is corrected, decoded, and translated back into useful information. Then your phone takes action. That action might be opening a website, showing a message, connecting to Wi-Fi, saving a contact, or confirming a ticket. In a world where speed and convenience matter, QR codes have become a simple bridge between physical spaces and digital experiences. They may look like small squares, but behind them is a smart and efficient technology that helps people access information almost instantly. The next time you scan a QR code, remember, you are not just taking a picture of a pattern. You are letting your phone read a tiny map of digital information built from squares, structure, and clever mathematics.